Once again, welcome to my YouTube channel, Pearson and Excel International Maths, and we continue to explain Pure Mathematics 1 in this video. And we now want to get deeper into topic number 8, whereby we are on page 154, and we want to further understand what differentiation in the first principle is all about. And we are having to deal with finding the derivative. And we are told that differentiation from first principle is not examined. It is included here to give a detailed account of where differentiation originates. And of course, you can use algebra to find the exact gradient of a curve at a given point. This diagram shows 2 points A and B that lie on the curve with equation y is equals to fx. Okay, let me just put the diagram so that we are on the same page. The diagram looks like this, and we are having a curve that looks like that, and there's a point A there and there's a point B there. And this is the curve of y is equals to a function of x, just a general. And we are told that there's a point A here and a point B there. As B moves closer to A, let us see that as B moves closer to A, what happens? The gradient of chord AB, the gradient of chord AB, let's just put chord AB here. The gradient of chord AB as B moves closer to A, the gradient, that is another B, it can be there. As B moves closer to A, we can also have B there. So as B moves closer to A, the gradient of chord AB gets closer to the gradient of the tangent of the curve at point A. We happen to have the tangent of the curve at point A, and we said the tangent is the line that touches the line on the ones, and this is just the tangent. That is the tangent. Having said that, we are told that you can familiarize this approach by letting x coordinates of A be x naught and the x coordinates of B be x naught plus h. Now we may have something here, and we are talking about point A, x naught, that is and of course the x coordinates of A is x naught, and the y coordinates of A is the function of x naught, because y is given by the function of x. At this particular point, the coordinates of point B, the x coordinate is x naught plus h, and of course the y coordinates happens to be the function of x naught plus h, the function of the value of x at that particular point. So it goes without saying, if we will ever want to calculate the gradient of the chord AB, we will say that the gradient of AB is going to be the change in y, which is f x naught plus h minus f x naught all over the change in x naught plus h minus x naught. So it will eventually always be equals to the function of x naught plus h minus the function of x naught all over x naught minus x naught becomes 0 all over h. And that is the general gradient function. The general gradient function. And we talk of if we may ignore the x naught and just make it as general as it could be, then we are saying the derivative of x is always given by the function of x plus h minus the function of x all over h. What is this h? This h happens to be this horizontal distance between A and B. That is the h we are talking about. That is the h. So as h reduces, then we need to see what happens to the gradient. Now, the gradient function can be used to find the gradient of a curve for any value of x. Now, we are told in the pink pages that as h approaches 0, the limit as h tends to 0, you can't evaluate the expressions when h is equal to 0. But as h gets smaller, the expression gets closer to the fixed or to a limiting value. Let us just see how this one can be used to give us a gradient of a curve. And we are told that using this rule to find the derivative is called differentiating from first principle. And as to elaborate this further, we now need to talk about example 2. But before we go on, I would wish to end this video there and start example 2 afresh in the next video. But before I leave, it is important to repeat very key points here, saying that when we want to find a derivative of a function, then because we said the gradient of a curve is equal to the gradient of the tangent at the very point of contact, now we have outlined A and B, and as B gets closer to A, then this chord tends to be this tangent. That is true. So we have also outlined that if we practically have A and B, and the coordinates of A and the coordinates of B, then the gradient is the change in y, over the change in x. And of course, as h approaches, as h approaches 0, we will see what happens when h now tends very close to 0. All right?